Question 3. Okay, figure 1 is a Venn diagram showing a number of students in the class who read any of 3 popular magazines, magazine A, B and C. One of these students is selected at random. Show that the probability that the student reads more than one magazine is 1/6. Okay, Venn diagram's been done for us. We just need to interpret. So what regions represent reading more than one magazine? It's going to be the overlaps. And I'm looking for an overlap here. And there's one more here. Everybody else either reads just one magazine or no magazines. So we're looking for those 5. So those 5 that I've highlighted out of everybody. And the total there is 30. And that cancels down to the 1/6. Just what we're looking to do, show that questions, give us confidence because we know we've got our answer, we know we've got our marks. Okay, so B, find the probability that the student reads A or B or both. Right, so the phrasing there should be familiar. A or B or both is A union B. And in that case, we're looking for anything contained within set A or set B. And that does include things that are in both A and B. So how many are we looking at? 14 out of the 30, which cancels down to 7/15. Okay, next we're asked to write down the probability that the student reads both A and C and explain what this probability tells us about A and C. So the probability that a student reads both . So we're looking for the overlap in between A and C, and it doesn't exist. The intersection of A and C is 0. What does this tell us about event A and C? They are mutually exclusive, meaning that they can't both happen at the same time. A and C are mutually exclusive. There was nobody that was in the intersection of those two. Okay, given that the student reads at least one of the magazines, find the probability that the student reads C. So we're going to make use of our given formula. Probability of A given B equals probability of A intersection B all over the probability of B. Event A is the fact that a student reads magazine C, and the event B, which is the given event, the given probability, is that the student reads at least one of the magazines. Okay, reading at least one of the magazines is basically everything inside any of the circles. And reading magazine C is just this section here. Okay, so the probability that they read C, given that they read at least one, okay, so that's going to equal probability of reading C, which is 9/30, divided by at least 1, which is 20/30, cancels down to 9/20. Okay, and finally we were asked to determine whether or not reading magazine B and reading magazine C are independent. Okay, 2 events are going to be independent if the probability of one multiplied by the probability of the other equals the intersection. This statement will be true if they are independent. So let's go ahead and see whether or not this is true. And that's our test of independence. Okay, so the probability of B is 10/30. Probability of C is 9/30. And that is going to equal 1/10. What was the probability of B intersection C? Well, that was 3/30, and 3/30 does actually cancel down to 1/10. All right, therefore, B and C are independent. Okay, so this initial statement for the test of independence, the actual calculations that show that it does work, and this final statement, include all of that. That will be worth all your marks.